I don't know. We'll see what you guys think. I think it's a little confusing. We'll see what you guys think. Okay, I gotta share my screen here. Give me 1 second. Okay, first thing that I'm going to talk about today is second hour today and tomorrow. When you're in class, you're going to get all of your registration material. You're going to watch a video by Mrs. Collison, and she's going to go over some things for you, but I just wanted to let you know as far as math goes, okay? Now, is there anyone in here that has not taken geometry? Everybody's taken geometry, right? Okay, so your next class that most kids take after geometry is College Intro to Stats. So if you would have had to take the Accuplacer, and you'd have to get the 255 or above on that first test, okay? The first test was called the QAS. And so you would have had to taken that and got the 255. This is a 4-term class, so like 2 trimesters. And then depending on, some of you are freshmen right now, some of you are sophomores. Depending on how tight your schedule is, a lot of kids, their first year that they're taking college math will also take college trig. And there is a trig class and a college trig class. They are both the same book and everything. The college trig just goes faster and it would be a little bit harder, but it is the same book. This is 2 terms, so a lot of kids try to take both of these in the same year. Now this one, the college trig, you would have had to get, wasn't it a 250 on the AAF, I believe, to get into this one? And this one, you would have to get a 255 on the QAS, okay? Now, do any of you have a college class now? Okay, are you guys in Intro to Stats now?
I think so. So it's college stats.
Yeah, yep. Yeah, college stats, yep. So then next year, are you guys, so you wouldn't be doing college trig, right?
Yeah.
So then and you're both sophomores, juniors. What I would suggest for you guys, if you got the 250 on the AAF on that test, you would have to do that. Mm-hmm. If you did, I would suggest you take college trig, but more importantly, I would try to get in college algebra before you guys graduate, because college algebra is a class that a lot of colleges make you take. And so this would cover that. A lot of majors in college, you only have to take 1 math class, and this would be one that you would work. Both of my kids, or 2 of my kids, maybe even 3, they all had to take a stats class. Caden's going for nursing. This worked for her stats. Chase is going to be a guidance counselor. He needed a stats class. And Tyler's an accountant. He needed a stats class. So this covered their stats class in college. So if I was picking and choosing classes, we all need a stats class to graduate from here. So I would take this one for sure, and then college algebra also. And then those of you that are in 9th grade right now, you have the opportunity to take this as a sophomore and then as a junior, as a junior then, what I would suggest you do is take short course to Calc, which is also a college class. And that's 2 terms. And then I would, as a senior, take Calc 1. And this, I believe this year is a 4-term class. We just switched that, and these are each 2 terms. Okay? So if you're in 9th grade, that's what I would suggest. Those of you that are in 10th grade right now, I would do this in 11th, and I would do this in 12th. Unless if you're going, the thing is, you all may think you're going into a certain major. The chances of you actually going into that major are kind of slim. Most people change their college major. And if you think there's any chance that you're going to go into something that you have to take Calc in college, I would do my best here to take this course. And then if you're a freshman, try to take this course here. Okay? Does anyone have any questions? All right, so most of you are going to do these 2 next year if you got the AAF score. If you got close to it and you're going to retake, you could still sign up for it. If you didn't get close to this, just take the college intro to stats. Okay? Questions on anything? All right. So like I said, today's assignment is kind of tough. So we are going to be doing a parabola as well as the absolute function, which is that V-shaped graph. And we're going to be moving those graphs on the axis. And there's many different ways that you can move it. So first, you can move it either left or right. Okay. The second thing you can do is move it up or down. The third thing you can do is if there's ever a minus sign in front of the function, you can reflect it across the x-axis. What that means is if it normally looks like this, remember our x-axis is like this, so it would instead, that should actually touch that, go upside down like that. You can also reflect over your y-axis, okay? That would be an option. The other thing that can happen is you can have a vertical stretch and a vertical compression, and we'll show you what that looks like, as well as a horizontal compression or a horizontal stretch, okay? So what we're gonna do, instead of me explaining all of this, what we're gonna talk about first is what happens when we have, so our functions, what I tried to do is show you what our functions look like. The absolute value one and a parabola. So the normal absolute value function looks like this. Okay, that's our normal absolute value function. That is just a V going up, okay? Our normal parabola, our general parabola function looks like this. And what we're gonna do today is make changes to those. The first thing we're gonna do, we're gonna just look here at this absolute function, is what happens if inside that absolute value, you add or subtract a number to it. And what happens is, if that number is added to it, you're gonna take your whole graph and you're gonna shift it that many units to the left. It's actually opposite of what you'd think. Like if I looked at this and saw +4, I would think it's gonna move 4 to the right. It actually moves to the left, okay? Then if you have your parabola, what they do if you add or subtract something to it, it's going to look like this. Okay? If you add or subtract something inside of that function, if it's minus, okay, what you would do is move that whole thing to the right. If it's plus, you move it to the left. The other thing that can happen, which is actually easier to see, is you could have something like this, where you have y equals the absolute value of x. That's called your parent function, okay? That's like the original function. If you just add a number at the end, that number tells you how much to move the whole graph up or down. If it's plus 4, we go up 4. So there the numbers kind of make sense. If it's plus 4, I would think it's going up. If it's minus 4, you would go down that amount. And I gave you guys all this table, and you can use that table on the test, so you don't have to memorize these. Now, down here, if you ever have the absolute value of x, that's your parent function, and you subtract 4, that tells you you're going to go down. If you have your parent function, which is y equals x squared, and you subtract 4 from that, again, you're going down 4. So just so you guys see the difference here, in this one up here, notice the plus 4 is inside the absolute value, and here the plus 4 is inside parentheses, and that's squared. Down here, these plus 4s are kind of tacked on at the end, okay? So what we're going to do, my problems are all going to get set up like this today, where they have you graph the parent graph, which in this case is y equals absolute value of x, and then y equals absolute value of x plus 2. Now, when we first get started, we're going to fill out tables for each of these. But as you get going and you start saying, well, I don't really need those, I can kind of see where it's going to go, then you don't necessarily have to use these tables. But at the beginning, until you get used to it, I would suggest it. So what I would do here, guys, is I would put in -2, -1, 0, 1, and 2, and maybe even -3 to +3, okay? The absolute value of -2 is 2. The absolute value of -1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. So if I go to graph this, at -2, I'm going to go up to 2. At -1, I go to 1. At 0, I go to 0. At 1, I'm at 1. At 2, I'm at 2. And you can kind of see the pattern that's going to happen here is you're going to have a V that kind of has a slope up one, left, right one on the right side, and it has a slope up one, left one on the left side. Now, one thing that I noticed going through the tests, some of you, a couple of things, homework and tests. You have to use graph paper when you turn these in. I do not want to see assignments coming in on notebook paper. Grab graph paper if you're low on it and make sure you use that. Make sure you use a ruler when you're graphing or a straight edge of some sort. And your graphs have to cover the whole graph. I don't want to see a little arrow here and your graph stop like way down here. I want the graph to cover the entire graph, okay? That is our parent function. Now what we're gonna do is we're gonna graph this, okay? And we're gonna put in those same points, -2, -1, 0, 1, and 2. So the absolute value of -2 is 2, plus 2 is 4. Absolute value of -1 is 1, plus 2 is 3. Absolute value of 0, 0 plus 2 is 2. Absolute value of 1 is 1 plus 2 is 3. Absolute value of 2 is 2 plus 2 is 4. Okay, so for this one, we're going to graph this on the same thing. We go to -2 up 4, -1 is up 3, 0 is at 2, 1 is at 3, 2 is at 4. And again, the slope on the right, you're just going up 1, right 1. And on the left, you're going up 1, left 1. Okay, now what you have to do then is describe the translation. Don't forget to do that part. In this one, when it's a +2 like that, if we look at our chart, that is this situation here. Okay, this one right here, where you're adding something after the absolute value. And when you do that, you're supposed to move your graph up that amount. So this is moving your graph up 2 units. Okay, and as I was saying, once you get good at this, you always have to graph the parent graph and the new graph. So you're always going to have 2 graphs, but you may not have to do these tables every time. Okay. All right, so if we look at this one, notice there's a -7 at the end. Okay, so that's going to be like this down here. Okay, and what it tells us is we should be moving that, the absolute value of k. Well, k is -7, so the absolute value of that would be 7. So what should happen with this one is we're moving it 7 units down. But this one's different because our parent graph of this one is just y = x squared. Okay, so what I did is I put y = x squared here. And again, I'm going to just do -2, -1, 0, 1, 2. And here we're squaring them. Do you guys know when you square a negative, what happens? Positive. So this would be 4. When you square a -1, when you square a negative, it's positive. So this is 1. Square 0 is 0. Square 1 is 1. Square 2 is 4. Okay, so let's go to our graph. And at -2, we're up to 4. At -1, we're up to 1. 0, 0. 1 is up 1. And 2 is up 4. Now, I'm just going to add a point here and here just to kind of finish off our graph. -3 squared is going to be a +9, and a +3 squared is a +9. So I'm going to add those 2 points. So if I go over to 3, I'm going to go up to 9. If I go over to -3, I go up to 9. Okay, this is my parent function. Okay, now what I'm going to do is I'm going to try to do that same graph, but I'm going to use the new function. So let's do -3, -2, -1, 0, 1, 2, 3. A -3 squared is a +9 minus 7 is 2. A -2 squared is a +4 minus 7 is a -3. -1 squared is 1 minus 7 is -6. 0 squared is 0 minus 7 is -7. 1 squared is 1 minus 7 is -6. 2 squared is 4 minus 7 is -3. 3 squared is 9 minus 7 is 2. So let's graph that. -3 up 2. -2 goes down to a -3. -1 goes down to a -6. 0 is at a -7. 1 is at a -6. 2 is at a -3. 3 is at 2. So here, if I draw my parabola, so like I said, make sure the graph covers the entire, or the line covers the entire graph, okay? Now, we got our 2. We just have to say, what did we do? So looking here, we subtracted 7 to x squared. So we moved it 7 units down, which is what it looks like we did, okay? So it's 7 units down. Questions on that? Okay. So now if I go to this one, notice in this one, they're adding 3 inside the absolute value, okay? So if I go down, that's this right here. They're adding the 3 inside. And so just to look at what it says we would do is we should move it then, because it was plus 3, we should be moving it 3 units to the left, okay? Now, if I wanted to, I could try to do it without my tables, but I'm gonna, for this one, do my tables again. So absolute value of -2 is 2, this would be 1, this would be 0, this would be 1, this would be 2. So what I do is I just know what the absolute value function is. And it's just starts at 0, 0 and goes up 1, right 1 to the right, and up 1, left 1 to the left. Okay, then if I look at this next one here, notice inside here is a plus 3. So I could try those same numbers. Sometimes I don't guess the right numbers and I have to change it a little. But for -2 plus 3, I get 1, absolute value of 1 is 1. -1 plus 3 is 2, absolute value of that is 2. 0 plus 3 is 3, absolute value is 3. 1 plus 3 is 4, absolute value is 4. 2 plus 3 is 5, absolute value is 5. So if I go to graph this one, I'm at 2, 1, or I'm sorry, -2, 1, -1, 2, 0, 3, 1, 4, 2, 5. But notice that only gives me 1 of the halves of my V, okay? And do you know how we talked about if there's a plus 3 in there, you should be moving it 3 units to the left, okay? Knowing that, I'm gonna assume this is where my vertex, like where the V starts is called your vertex. Notice that is 3 units to the left. And what you can do then is just from that vertex, go up 1, left 1, up 1, left 1, up 1, left 1, because your absolute value is going to be up 1, left 1 in a situation like this. Okay, so what we did is we took an absolute value and we moved it 3 units to the left. Okay. Now this next one, notice that plus 1 is in parentheses. So if we go down to our table, that's going to be like this one right here. And when it's plus, that tells you how many units you're moving it to the left. And ours was plus 1. So we should be moving this one to the left 1 unit. Let's do our y equals x squared first. And here's how you can make this a little easier on yourself. You always have to do the parent function. If you just remember, like think about 0, 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. 1 squared again on this side is going to be positive 1. -2 squared is positive 4. -3 squared is positive, 9. So you don't really have to use that table if you can kind of just look at it and do that, and then draw this. Okay, now we talked about already that this should be shifted 1 unit to the left, okay? You can either make a table to decide how that would be, or I just want to show you in case you'd rather do it this way, move every point 1 unit to the left. So you know how I had 0, 0, move that to the left. Over 1, up 1 was a point, move that point 1 unit to the left. Negative 1, 1 was a point, move that one to the left. This was a point, move that one to the left. This was a point, move that one to the left. And then over here is a point, move that one to the left. And then you can just connect those. Does that make sense? Or would you guys fill out your table? No, you'd probably just shift it. So this one is going to be 1 unit left. Okay, so you make sure you graph both and that you explain what you did. Okay, now this one is just asking us to describe the translation. They are not asking us to graph these. So if I had the -4 inside the parentheses squared, that's going to be like this right here, okay? And if it's -4, you're going to move that many units to the right, okay? So that is just taking the normal y equals x squared, and we're shifting it 4 units to the right. This one, notice it's the absolute value function, and then it's a +3. +3 after the absolute value function, that tells you how many units to move it up. Okay, so this one is going to be 3 units up. This one has 2 things going on. First thing is that it has a number inside the parentheses. So if you look, it's going to be this situation right here. And if it's plus like ours is, it tells you how many units you're moving it to the left. So let's do that first. We're going to be going 3 units to the left. And then because it's -6, that's going to be this right here. And the minus tells you how many units down to go. So it's going to be 6 units down. You guys get that? Everybody understand that? Okay. Now, let's look at this one, okay? So here again, we have 2 things going on. It's the absolute value function. So what I do here, guys, is I would just go and do my absolute value function right away on the graph. And if you remember, the absolute value function starts at 0, 0, and it's that V that goes up 1, right 1 to the right, and it goes up 1, left 1 to the left. So that's your parent function. So now we could talk about what this one should do. If it's +3, do you guys know what that would do to it? It would move it up 3, right? Do you guys get that? And if it's +2 inside the absolute values, do I move it 2 to the left or 2 to the right? 2 to the left. Do you guys get that? Mm-hmm. So it's like up 3 is this, okay? And then it was +2, so that is this. And that tells you how many units to the left. So in this one, we are moving it 2 units to the left and 3 units up. Now, with the absolute value, once you determine that, if you don't want to make a table for the new one, you could just go to that vertex, the bottom of the V, and move that point 2 to the left and up 3. 1, 2, 3. And then remember that function goes up 1, right 1, up 1, right 1 to the right. And then it goes up 1, left 1 to the left. Now, if I were you, I'd probably go back and like check a point, like maybe put 0 in here and see if it should be at 5. 0 plus 2 is 2, absolute value of 2 is 2, plus 3 is 5. And then maybe put in like, I don't know, -5 maybe. If I put in -5, -5 plus 2 is -3. The absolute value of that is 3. 3 plus 3 is 6. Go to -5 and see if you're at 6, and I am. Oh, wait. -5. Yes, I'm way up here. I'm looking at the purple one, not the pink one. Yeah, -5, I'm at 6. Okay, so you can check it. And if you don't like that way, you can certainly put values in here and graph it. All right? So now we're going to talk about reflections and dilations. And this is, I think, harder than what, especially the dilations is a little bit harder. So what happens is another thing you can do is have a reflection over the x-axis or a reflection over the y-axis, okay? When you have, so that's this right here. When you have a minus sign in front of your parent function, so it would be like this if it is a absolute value, or it would be like this if it is the parabola or quadratic function, okay? When it's in front, what happens is you would reflect across your x-axis, which just means, like if it's a V pointing up, it would be a V pointing down. If it's a parabola opening up, it would be a parabola opening down, okay? The other thing that could happen is the minus sign could be inside the absolute value, or it could be inside the parentheses squared. If it's inside, you're going to reflect it across the y-axis. And there's none that we do that we have to graph that. We do graph some, I believe, where you reflect over the x, but not over the y. But there is some questions where you might have to know, like you won't have to graph it, but it'll say what would happen to this? What would be the transformation of this? You still need to know it, you just may not have to graph it. So if I look down at this, notice that my minus sign is in front, it's not in parentheses, okay? So if it's not in parentheses, that's this right here. It's going to reflect across your x-axis, okay? So here's the deal. This one is a parabola. And if you remember this, a parabola, think about like 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. On the other side, a -1 squared is 1. A -2 squared is +4, a -3 squared is +9. That is your parent function. Okay, now if you wanted to, you could just put numbers in here. And what that would look like is minus a -3 squared. So if you squared a -3, you'd get 9. And then the minus in front makes this a -9. If you put a -1, you'd have minus a negative 1 squared. This would be a positive 1 with a minus in front is a negative 1. 0 is still going to be 0. A positive 1, 1 squared is 1 with a minus in front is negative 1. And then if we went to 3, 3 squared is 9, negative in front is negative 9. So it's just going to be that same parabola, but it's going to open down. So at negative 3, you're going to be at negative 9. At negative 2, you're going to be at negative 4. At negative 1, you're at negative 1. You're still at the origin for the vertex of it. At positive 1, you're at negative 1. At positive 2, you're at negative 4. At positive 3, you're at negative 9. So it opens down. Okay, so this one is going to reflect over the x-axis. So if I folded this line over my x-axis, it would map onto each other. Okay. All right. Then a dilation. Okay. This is where you're taking your absolute value, like that V, and you're either making it skinnier or wider. Okay. And then you can also move things horizontally, compress it, and stretch it. So here's the difference of this one. If your 4, or if a number is in front of the absolute value or in front of the x squared, and it's not in the absolute value, what depends, there's two different situations, and I should have tabbed this down. But if your absolute value of A is less than 1, it would be between 0 and 1, you're going to have a vertical compression. If the absolute value of what's in front of there is going to be greater than 1, you're going to have a vertical stretch. If you look down here, the 4 is inside the absolute values, and the 4 is inside the parentheses. If that is the case, you look at what is that number that is inside the brackets or inside of the parentheses. If it's greater than 1, you have a horizontal compression. If there's a fraction in front of it, and it's between 0 and 1, you're going to have a horizontal stretch. So let's go down and try one of these. Okay, again, the parent function would just be 0, 0, and this is just x squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9, negative 1 squared is a positive 1, negative 2 squared is a positive 4, negative 3 squared is a positive 9. And make sure you graph those points. Don't just sketch it. Make sure you plot those, 7 points? Okay, now when we go to put the 4 in front, when you get to the compressions and the stretches, if I were you, I would make a table on these, because otherwise it's hard to even know what to do. So I would probably go -3, -2, -1, 0, 1, 2, 3. Now, if you square a -3, that's 9. 9 times 4 is 36. If you square a -2, that's a positive 4. 4 times 4 is 16. -1 squared is 1. 1 times 4 is 4. 0 squared is 0 times 4 is 0. 1 squared is 1 times 4 is 4. 2 squared is 4 times 4 is 16. 3 squared is 9 times 4 is 36. Now, what I would do on this one is just only go to 10 and -10. And so really, the only points we're going to fit on our graph are these. Okay, the other ones are going to be off the graph. So let's try that. At -1, we're up to 4. At 0, we're at 0. And at 1, we're at 4. And then if you did do -2, it's way up here at 16. So it's going to be something like this. Okay. And again, what we had there is a number in front of our x squared. So, and our number was bigger than 1. So this is a vertical stretch. So it's like it's stretched it vertically, so it actually gets skinnier when it's a vertical stretch, okay? So if the number in front is bigger than 1, then it's a vertical stretch. So let's go here, and now we're gonna try one that has a number inside the absolute values, and it's less than 1. So if we go to our table, this is this situation right here. We have a fraction inside of the absolute value, and it is less than 1. So we are going to have a horizontal stretch. Okay, that's what we are going to have. So let's write that first. Now, when you go to graph the absolute value of x, remember that's our v, with a slope up 1 over 1 to the right on the right, and up 1, left 1 on the left. And make sure that you do those with a straight edge and that they're plotted all the way through. Okay, then when I do these, I put numbers in, and if it's 1/3, what I would do is use multiples of 3. If it was 1/2, I would use multiples of 2. So because it's multiples of 3, I would start with -9, -6, -3, 0, 3, 6, 9. If that was 1/4, I would do 8, -4, 0, 4, and 8. Okay. Now, 1/3 of 9 is 3. So if you took 1/3 of a -9, 3 goes into 9 3 times. So that's going to be a -3, but it's the absolute value of it. So it would be 3. If you took 1/3 of a -6, 3 goes into 6 twice. So that would be a -2. Absolute value of -2 is 2. If you took 1/3 of a -3, 3 goes into 3 one time, that's a -1. Absolute value of a -1 is 1. Put 0 in there, you're just going to get 0. 1/3 of 3 is just 1. 1/3 of a +6, 3 goes into 6 twice, so that's 2. And 1/3 of a +9, 3 goes into 9 3 times, so that's 3. So at -9, we're going to go up to 3. At -6, we are going to go up 2. At -3, up 1. Then we have that origin. At +3, it's 1. At +6, it's 2. And at +9, it is 3. So here, so it's kind of stretched horizontally. If you think of this being your horizontal, it's stretched horizontally. If it's stretched vertically, it's pulled up closer to the y-axis. If it's stretched horizontally, it's closer to the x-axis. Questions on that? Okay, so this is asking us to just explain what's happening here, okay? Notice here we have the 3 inside of the parentheses, okay? So that is going to be this right here, okay? So that's going to be, and I should say this, then you have to look at, is 3 bigger than 1, or is it between 0 and 1? And 3 is greater than 1, so we're going to have a horizontal compression. Do you guys get that? Now this one has the 3 in front of the x squared. It's not in parentheses. So that looks like this. And when you're doing these, remember it matters, is that 3 bigger than 1 or is it between 0 and 1? And 3 is bigger than 1, so you're going to have a vertical stretch. Now this one has 2 different things. It has this minus inside of the absolute value. That is this right here. Minus inside the absolute value means that you're reflecting it across the y-axis, okay? And this you could write, there's 2 things happening and you can do it in any order. It's not like you have to do one before the other. So we're going to reflect over the y-axis. Okay. Now we have a fraction, so something between 0 and 1 that is in front of the absolute value. So that is like this right here. We have a fraction in front of the absolute value. So that is a vertical compression. Okay. So you're going to say comma, vertical compression. Questions on that? Okay. Then this one here, we have to look at the parent graph and the new graph and just kind of talk about what would our equation be. Now, one of the things our book does a lot that I don't really care for is they number their graphs like by multiples of 2. So they're counting by 2s on both axes here, so you have to keep that in mind. So of course our parent graph is just y equals absolute value of x. That's our parent, okay? Now if you notice here, this graph went up and left, okay? If you notice, that vertex went up and left. It went up 4 and left. Can you guys tell that that vertex is like at -3, okay? And so it went left 3, okay? Now, the way that you do the left 3 is by putting that inside of here. And we can look at this. When we're going left and we have an absolute value, you put it inside of the brackets. And ours was left 3, so we would go the absolute value of x plus 3. And like I was saying, that's the one that I think it's opposite of what you would think. I would think if you're going to the left, it would be negative, but it's actually plus, okay? Then it went up 4, and when it goes up 4, that tags on the end, and that is what we would expect. That's right here. So you just go plus 4 at the end. Okay. Then if you go down to this one, the parent function is just y equals x squared, and we want to look at what happened to that graph. For one thing, it flipped upside down. So what that means is it was reflected over our x-axis. Okay, so that's one part. The other part is we have to talk about how was it moved. This was moved over 2 to the right. Do you guys get that? And up 1. The vertex of it is up here. So it was moved 2 to the right and up 1. So 3 things are happening here. Okay, and again, we have to try to write it. So we're going 2 to the right. Let's do that first, and we're dealing with y equals x squared. If you're going 2 to the right, it's going to be a minus inside of the parentheses. Okay, so it's going to be y equals x minus 2 quantity squared. The up 1 is where you take that on the end. So up 1 is here. You just take that plus 1 on the end. And then we have to deal with reflecting it over the x-axis. So if we look down, reflect it over the x, the minus sign goes in front, not in the parentheses, just goes in front. So what you would do is just put a minus sign out front there. If it was reflected over our y, which like I said, I don't think we have any that you do that on the graph. There is maybe a question where you have to look at an equation and say how it transforms. But if it was reflected over our y, then it would have the minus sign inside of the parentheses. Okay, so your assignment looks like super big because I listed all individual problems. So let's look here. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 problems. Okay. So make sure you have enough graph paper for that. Did you guys think it was really hard? No? Not too bad? And then if anyone has individual questions for me about registration, please don't hesitate to ask. Those of you at home, do you have any questions for me on either today's assignment or registration? So once you get your assignment done, those of you at home, you are free to go, unless you have a question for me, okay? Have a great day, guys.